Hi all, welcome to another learning support video. This week we're going to continue explaining some weird and wacky observations that you guys might find in your everyday life. And I decided what better way to go on this week with what causes gas containers to explode in direct sunlight. So all of you would have probably bought a gas container of some sort in some time of your life. So whether it's deodorant or spray and cook or like any type of aerosol can, guys, all of those cans, if you guys have noticed, they have a warning on them saying that you must not leave the can in direct sunlight. And what I'm going to explain to you is why we can't leave it in direct sunlight. A lot of you guys might know is that it's because that there's a chance that it'll explode in direct sunlight. But let's go look at why it explodes, guys. And to do this, we need to have a little background information, guys, is that there are 3 gas laws about ideal gases. So basically how most gases work. So not all gases, but most gases should work in this way. And these 3 different scientists all found different conclusions. Charles found if pressure remains constant and temperature is increased, the volume of the container will also increase, guys. So what that's saying is that if you have something with a set pressure and you have a very variable like container, so like something like a balloon's a nice way to remember it. If you take a balloon and you fill it up with air or let's say deodorant or whatever gas you want, guys, if you fill up that balloon with it, okay, if the pressure inside that balloon will always remain constant no matter how much you fill it up, guys, because the shape of the balloon is just going to keep on expanding the more and more gas you put into the balloon. So no matter how much you try increase the pressure, you won't be able to, because the balloon will just keep on expanding until it explodes, guys. And what this actually saying is that if we take a balloon and it's filled with a gas and we decided to heat up the balloon somehow, like in a way that we don't actually pop the balloon while we're doing it, if we heat up the balloon, you'll see that the balloon will grow because the temperature is increasing inside. So, and because pressure can't increase inside the balloon grows to account for the fact that pressure can't change. The next one is that if temperature is kept constant, a decrease in volume will cause an increase in pressure, guys. And again, this is well explained with a balloon, guys, is that if you blew up a balloon filled with air, and like when you try squish the balloon, guys, it doesn't just crumple away, and it doesn't just, like, you can't just fold it up like you could if there was nothing in the balloon, guys. This is because the gas inside the balloon exerts a pressure, guys. So when you try squeeze the volume of the balloon, try decrease the volume of the balloon, guys, there's an increase of pressure because the gas is resisting this change in volume, guys. So it increases its pressure to try and stop you from decreasing the volume, guys. So that's why when you squeeze a balloon, you'll feel the more you squeeze it, the harder the air will actually press back at you. Then the last type is Gay-Lussac's observation, and it was if volume is kept constant, an increase in temperature will cause an increase in pressure, guys. And this is actually what we're going to be looking at, guys, is that this is what applies to deodorant cans. I'm going to go into a bit more detail on how it goes. But what you need to know, guys, is that all 3 of these rules were combined to make the equation of an ideal gas. We'll go into more detail of it in future videos, I'm sure. But basically, all of these 3 observations, there was one other observation called Avogadro's observation, but we're not going to include that for now because it really doesn't apply to what we're working on. So why does the can explode, guys? As I said, that this is due to the 3rd law about gases. It was Gay-Lussac's observation, guys. It's if the volume is kept constant, an increase in temperature will cause an increase in pressure, guys. And like a lot of you can probably see how this already applies, I think. Okay, so the deodorant can's volume is constant, guys. Makes sense, is that deodorant cans are very solid and hard, is that you can't change the volume of a deodorant can. So the deodorant can is constant, and if we look at the 3rd law, if volume is kept constant, so that's the first part of that law already proved, okay? And then the next part is deodorant cans are pressurized, so it initially already has a high pressure, okay? That's just a fact, guys. All deodorant cans or spray and cook and all that stuff, because they're aerosol, they're very high pressure inside. That's why it comes out. We're able to spray them and it comes out at such a high velocity. It's because there's a high pressure already in the can, okay? Leaving it in the sun causes the temperature to increase, okay? So now if we leave our deodorant can in the sun, the temperature of the gas inside the can starts to increase, okay? And what did we know about the third law, guys? The third law about gases stated that when the volume is constant, which it is, which we already talked about, and the temperature is increased, which we talked about here, because leaving in the sun causes the temperature to increase, the pressure in the container will increase. So now that we've left it in the sun, this can already had a high pressure in it, but now that we've left it in the sun, now the pressure is just getting higher and higher. It's building up because the gas is getting hotter. So all those molecules have more energy. So then the pressure therefore carries on increasing until the container cannot take the force anymore, causing the can to explode, guys. So this is basically the same thing as the balloon, is that once the pressure gets too high inside that container, the can can't take it anymore, so it just explodes because it cannot withhold that amount of force taken from the can. So this is the reason why gas cans explode when they're left in direct sunlight. Thank you for watching another learning support video. I will see you guys tomorrow. Thank you.